We all watch movies. And we all know that a lot of technology is used to create movies. But ultimately, movies are about storytelling. So let me tell you a story, funny one. A man walks into an Irish bar, and there are lots of faces. He goes and sits next to an old man. The old man has a face which is very sad. And then he looks around, there are lots of other faces. He's looking their way and giving them glances and sniggering. So he asks the old man, what's wrong? So the old man gets up, he slams down his beer, and he says, you see that bar? I built that bar with my own bare hands. Bought the finest wood in the county, I cut it, and I put it plank by plank by plank. Give it more love and care than my firstborn. But do they call me McGregor, the bar builder? No. Points out of the window, he says, see that bridge? I built that bridge with my bare hands. I bought all the rocks from the county. I placed them side by side by side. Took me 6 blooming months. Do they call me McGregor, the bridge builder? No. Points to the other direction. See that pier? I built that pier with my bare hands. I poured down the piles plank by plank by plank through the tide and the sun and the wind. But do they call me McGregor, the pier builder? No. But you fuck one goat. So now, if this storytelling is about communicating a setup, and if this setup was to unfold in front of your eyes in a cinematic manner, you would have McGregor, the actor, and all of us would cue in onto his face to understand the frustration and the emotional and empathy that is going through. Now, in today's world of storytelling, with the creative powers that be, we need to have digital actors with digital faces. Now, it turns out that faces are very important to communication. None of us in this room has not looked at our faces since the morning. But turns out in computer graphics, building a face, building a real face, animating it, and rendering it is one of the most challenging problems and expensive problems today. So today we know a lot more about faces. From a neuroscientific point of view, we know that there's a special dedicated area in the cortex that is specialized and dedicated just for facial processing and facial activation. From a psychological perspective, you know how important faces are to behaviors. From a engineering perspective, you can very unceremoniously think of a signal as a multi-channel signaling device. So let's go back to 2002, when the entire industry was reeling in the success of a movie, Lord of the Rings, which had its first digital character, Gollum, which took screen space for a long time. And so when big Hollywood directors were like Robert Zemeckis, Steven Spielberg, James Cameron were coming to our studios at Sony Pictures and others with their projects that had multiple digital characters and multiple digital faces, we knew we need to have a scalable solution to build these faces and animate them.
Yes,
So
are you nuts?
So the goal we went down was called performance capture. And in performance capture, the idea there is instead of animating all the faces and bodies by an animator, we help them by trying to capture the essence of acting by having an actor act as directed by a director and use those signals to drive a digital character. So
Yes,
here's an
are you
example.
nuts? I don't want to steal drugs from my father. I don't want to go inside a monster, and I don't want to die.
I say it's worth a shot.
Yes, I agree. Let's do it.
So it shows you a director directing all the actors, and there are systems that are capturing those signals, and there are algorithms that are driving all the faces and bodies together. So there are two big problems to solve that we had to go down on the route on. One was to capture an actor's performance as directed by a director, and this is mostly an engineering problem, to devise sensors and systems to capture all those signals. And the second one, which was more like a new ground to us at that point of time, was to translate that performance and transfer it onto a digital character. And for this, we had a confluence of multiple fields, from biomechanics to psychology to computing also. And so we built these systems where we had actors put on lateral reflective markers And this is borrowed from motion capture, but it was never built to this scale. We had about an array of 300 machine vision cameras that were capturing all this data and trying to make sense of it ultimately. And initially, it started off with all these actors acting together. And this is a big challenge because there was no system built that could capture 20 minutes, 20 actors together to come up with a performance capture film. And at first, the systems had a high footprint with all those cameras, but later on we moved to a more lesser footprint of technology on set where we could use a few video cameras. In all this, one thing to point out is this problem space was daunting, yes, but most of the solutions that were required for this were kind of not known, but at least we're privy to this research going on in computer vision at that point of time, especially at the University of Oxford, Carnegie Mellon, and all around the world, where we could deal with optical flow, tracking, multi-view geometry, and 3D reconstructions. But a bigger problem that we had to create next or solve next was how do we use it to drive a digital face? Faces are very important because as you get closer and closer to reality, you can really make out any micro-significant difference that affects your communication or understanding what the digital face is saying. And so for this, we had to go think out of the box and talk to plastic surgeons in Beverly Hills. We talked to medical experts, facial anatomy, psychologists, and ultimately we honed down on this theory where we borrowed from psychology, which is called the facial action coding system. And with this is the first theory that was actually metrically measuring a face. And what this theory says is that although there are lots of muscles that drive your face, they group together in something known as action units. And Paul Ekman, who propounded this theory, showed us how many empirical action units there were. And he also had a way of subjectively measuring them. But when you look at this subjective measurement, an engineer would think of a regression, and we tried to replace it by their actual motion capture equivalent to performance capture equivalents, and we could then solve this to make a mathematical solution. So we went into a room and calibrated all these actors making all these faces, all these action units, and I had a good time playing a director role for the first time in my life, capturing all these faces. And ultimately, these go to then drive a digital face. So let's see some early examples that we use. So here is a system at work.
Anything to help out my...
Okay, there should be sound on this.
Just wait, the wily may roam.
Anything to help out...
Always a hero comes home.
And finally, here is another version.
Anything to help out my friendly
To make it
neighborhood
look
Spider-Man.
Close to reality.
You can't comment. I said, leave me alone.
And finally, I'd like to give you, in the remaining few minutes, a good example of how these technologies were used to create different animations in the movie world that I worked on. And so finally, to end, a few words on where these technologies have gone or are going. Nowadays, with with more stronger computational sensors and smarter algorithms, you will find these algorithms of driving faces makes their way towards simple applications of communication. For instance, Snapchat filters use similar technologies. But overall, I think when you think of communication, it's plausible to think how your own actions can lead to telepresence, and there are technologies coming out with that soon into the future. But a differentiating point is that all these are they still work by mimicking. You have a performance being performed, and it's being mimicked. It'll be an interesting world, especially in the world of AI, when all these systems start working by activation, where muscles get activated in response to a stimulus, and you have an AI system that can drive and give a face to all the communications. And so lastly, since this is about movies, and I went to Kharagpur, I have to end my talk on Tarapodo lights.